3 days, 180 tons, 0 roads built. That's what it took for a fleet of unmanned aircraft to deliver enough steel and concrete up a Chinese mountainside to build 3 power transmission towers, a job that used to eat an entire month of mule trains and hand-built cableways. You heard that right. And no, this isn't a prototype teaser. It's a completed, state broadcast verified operation run by an actual regional power utility. Let me tell you what that actually means in plain English. If you've ever watched a construction project stall for weeks because equipment couldn't get up a hill, you already understand the problem this solves. But here's the part that blows people's minds. This fleet isn't even the strangest or most advanced drone China has flying right now. It's no accident it landed at number 1. Hit like and subscribe, because by the end of this video you're going to understand exactly how 10 wildly different classes of drone are quietly rewriting entire industries. Number 10 on this list does not look like much at first glance. That is exactly the point. Picture a farmer standing at the edge of a field that used to take an entire day to spray by hand or by tractor, breathing in chemicals the whole time. Now picture that same field finished in 20 minutes, from the air, with nobody standing in the spray zone at all. That is the baseline this entire list starts from. The machine responsible is the DJI Agras, a squat, spider-legged agricultural drone that has quietly become the most widely deployed aircraft in farming history. As of this year, roughly 600,000 of these units are working fields in more than 100 countries, treating over 300 different crop types. The United States has somewhere around 900 million acres of farmland in total. DJI's fleet alone has already sprayed and seeded more ground than that. Here's what most people get wrong about drone technology in China. They assume it is all showpieces and military hardware. The truth is duller and far more consequential. It is a spider-legged crop sprayer quietly changing how the entire planet grows food. Number 9 takes that same logic and puts it in the sky above your dinner. Meituan, the food delivery giant behind roughly 1 in 3 restaurant orders in China, has pushed its drone network past 900,000 completed deliveries, running more than 70 routes across 6 cities, including Shenzhen, Beijing, Shanghai, and as of last year, Hong Kong and Dubai. SF Express runs a parallel network for parcels and medical supplies. Neither of these is a pilot program anymore. Meituan's system now holds a nationwide operating license from China's aviation regulator, the first of its kind ever issued. The kind of approval that took Western drone delivery companies years longer to even request. The part nobody covers is what happened to the actual delivery time. 10 to 20 minutes. Tap to pick up, beating a ground rider by up to 25 minutes during rush hour. Not a novelty. Infrastructure. And infrastructure, it turns out, is only the warm-up. What comes next does not spray a field or drop off a lunch order. It watches you. Number 8 is small enough to disappear between 2 fingers. Something with 2 wings shaped like leaves, 3 legs thinner than a human hair, and a body you could balance on a fingernail without feeling its weight. Something that beats those wings 500 times a second and can slip through a cracked window without anyone noticing it arrived. That is the Mosquito drone, built by engineers at the National University of Defense Technology in Yunnan province, 0.3 of a gram, about 2 centimeters long, and on camera, genuinely indistinguishable from the real insect it is named after. Node student Liang Hexiang held it between 2 fingers on state broadcaster CCTV-7 and called it especially suited to reconnaissance in confined spaces, which is a careful way of saying it can go places no larger machine ever could, behind a door, along a ceiling, into a room nobody expects to be watched. Here is what makes this genuinely extraordinary. Packing a power source, a camera, and a communication system into something the size of an insect is one of the hardest miniaturization problems in robotics, and engineers spent years failing at it before this design finally held together in the air. The battery alone at that scale is smaller than a grain of rice, and it still has to survive a wing beat fast enough to blur on camera. Number 7 trades stealth for brute force and solves a problem that has nothing to do with hiding. In Sichuan province last winter, a 500-meter stretch of an 800,000-volt transmission line disappeared under more than half an inch of ice, thick enough to snap steel cable under its own weight and black out entire counties for days. A drone lifted a de-icing robot 120 meters into the air, set it directly onto the frozen wire, and cleared the entire stretch in 15 minutes flat. Picture a window washing rig, except instead of squeegees, it is swinging a mechanical arm hard enough to crack ice off a cable thicker than your wrist, one careful strike at a time. State Grid Sichuan now keeps 5 of these drones and 5 robots on permanent winter standby, backed by 340 ice sensors strung across its highest voltage lines. The old method was a lineman on a rope in a snowstorm, hoping the ice broke before he did. Clearing ice off a wire is a maintenance job. What is coming next stops being about maintenance altogether. It starts being about fighting fires that nothing else on Earth can reach. Number 6 answers a question every fire department on the planet has quietly dreaded. What happens when the fire is 200 stories up, well past the reach of any ladder truck ever built? In Shenzhen, engineers recently pushed a high-rise firefighting drone to a new benchmark, a water stream powerful enough to travel 36 meters, fired from a hovering position 306 meters above the ground. Picture a garden hose that can still knock over a trash can from the length of a football field away, except this hose is flying, and the trash can is a burning facade no ground crew could ever get close enough to touch. Traditional fire trucks top out around 30 stories, sometimes less, depending on the equipment. This drone does not have a ceiling in the same sense a truck does. It has a battery limit, and that limit keeps shrinking every single year as the technology matures. Here's where the story really begins for a fire department, because for the first time in the history of urban firefighting, height itself stops being the enemy. Number 5 looks like nothing at all, which is exactly the design goal. Researchers at Northwestern Polytechnical University have spent years refining an Ornithopter, a drone that flies by flapping real wings instead of spinning rotors, nicknamed Little Falcon. In 2022, the same research group set a Guinness World Record for the longest flight ever logged by a wing-flapping drone on a single battery, 2 hours, 34 minutes, and 38 seconds. They later broke their own record, pushing past 3 hours in the air on nothing but flapping motion and a battery smaller than a phone charger. It sounds like it should not work. A mechanical bird flapping its way through the sky for hours at a stretch, generating lift the exact way a real falcon does. And that is exactly why it does. Most people who read about this never get past the novelty of a bird-shaped drone. Few stop to ask how brutally difficult sustained flapping flight actually is to engineer, let alone hold a world record in. Individual machines. Solving individual problems is one story. What happens when they start working as a coordinated team is an entirely different one, and considerably harder to pull off than any single aircraft, no matter how clever its design. A hovering water cannon and a flapping mechanical falcon both solve exactly one problem in isolation. Neither tells you what happens once a dozen drones have to trust each other's positions in real time with no room for error. Number 4 moves in swarms, not solo, and shows up precisely when the ground itself has failed. After earthquakes and floods, Chinese emergency response teams now deploy coordinated drone fleets that map collapsed buildings, relay thermal signatures of trapped survivors, and route rescue crews toward them in real time. Work that used to take ground teams hours, compressed into minutes, because a dozen aircraft can canvass a disaster zone faster than any single helicopter and see through smoke, dust, and darkness that would ground a manned aircraft entirely. No single drone in the swarm needs to be brilliant. It just needs to talk to the others, share position data, and hand off coverage the instant one aircraft's battery runs low. The same logic that keeps a flock of birds from colliding applied to search and rescue. Number 3 does not rescue anyone. It just refuses to stop growing. In February this year, over Lugang Park in Hefei, a company called Ahang Egret launched 22,580 drones into a single formation, controlled by one computer as part of the China Media Group's Spring Festival Gala. Only 25 failed to take off. That number alone would have been enough to rewrite the record books. It beat the previous mark of 15,947 by nearly 7,000 aircraft in a single leap. It was not the raw number that mattered most. It was that one control system could coordinate all of them, forming lanterns, cityscapes, and shifting formations in the night sky without a single mid-air collision. Number 2 puts a person inside the aircraft, except there is no pilot at all. Ehang's EH-216S is a 2-seat, fully autonomous eVTOL that received the world's first official type certificate ever issued for a passenger-carrying drone, granted by China's Civil Aviation Administration in 2023, after more than 1,000 days of testing and evaluation. Not a toy, not a concept model wheeled out for a trade show and never seen again. A certified aircraft, cleared for commercial operation, carrying 2 human passengers with nobody at the controls. And none of that. Not the swarm, not the flapping wing, not the aircraft with an empty cockpit, is number 1 on this list. Number 1 does not look futuristic at all. No lasers, no flapping wings, no formation of tens of thousands of lights. It looks like 16 ordinary cargo drones flying up the side of a mountain, carrying steel the way a delivery drone carries takeout. But a man named Wang Fangmin will tell you it is the entry on this entire list that mattered most, and by the end of this video, you will understand exactly why. Wang Fangmin runs planning and construction for Yunnan Power Grid Corporation, and in the spring of last year, he faced a problem that has broken construction budgets in southwest China for decades. 3 new electricity transmission towers needed to go up on a ridge in Zichu County at altitudes topping out around 1,650 meters. Karst terrain, sheer limestone cliffs, no roads, and no realistic way to build any without months of blasting and grading through fragile, protected forest. The standard fix in Chinese grid construction is a cableway, a temporary aerial tramline strung by hand, tower by tower, up the mountainside, taking the better part of a month before a single steel beam actually moves into place. Wang's team chose something almost nobody in Chinese grid construction had attempted at this scale before. Instead of building infrastructure to move the materials, they decided to fly the materials directly, using a coordinated fleet of 16 heavy-lift cargo drones. Here is what makes this genuinely extraordinary. Each individual aircraft in that fleet carries only a few hundred pounds per flight, nowhere near enough on its own to matter to a project of this size. But the drones flew autonomously along preset GPS routes, making dozens of trips a day, threading between cliff faces with a precision Wang later compared, on state broadcaster CCTV, to aerial courier delivery. Think of it less like one crane lifting one enormous load, and more like a colony of ants moving a mountain of grain. Individually unremarkable, collectively capable of shifting something far larger than any one of them could ever carry alone. No manual piloting was involved at any point. No margin for the kind of drift that would be a minor annoyance in open air, but becomes genuinely dangerous on the edge of a limestone cliff. Most people who read about drone construction projects never get to this part. The hard problem was never lifting steel. Plenty of drones can lift steel. The hard problem was coordinating 16 aircraft on tight, overlapping flight paths above a cliff face, with zero tolerance for a mid-air collision, and doing it well enough that a skeptical engineer with a career on the line was willing to sign off on it. Wang Fangmin had been circling this exact trade-off for years: build slower and safer, or fly faster and bet on the coordination holding. He chose the bet. The combined total the fleet moved needed independent verification before anyone outside Yunnan province would believe it. Here is the honest picture. No single drone in that fleet carries anywhere close to what the headline number suggests, and it is worth saying plainly before going any further. This was never one impossible machine. It was 16 ordinary ones, coordinated into something that added up to the impossible. Over 3 days, that fleet delivered 180 tons of steel and concrete up a mountain that had no road at all. State broadcaster CCTV confirmed the figure, and international outlets independently cross-checked it against Yunnan Power Grid's own construction records. 180 tons is roughly the weight of 30 fully loaded delivery trucks, moved without paving a single mile of new road and without felling the 2,000 trees a traditional cableway corridor would have required through that karst forest. The job that used to take a month took 3 days instead. Construction costs dropped by 80%. Labor requirements dropped by 60%, 10 times the efficiency of the old method, according to CCTV's own on-the-ground reporting. Here's what the honest picture does not erase, though. This method will not work everywhere. It depends on payloads small enough to break into drone-sized loads, weather calm enough to fly in consistently, and regulators willing to clear the airspace above a construction site for days at a time. It is not a replacement for every crane on every job site. It is a replacement for the specific, brutal case where no road can reasonably be built at all. That distinction matters more than the headline number, and it is the reason engineers, not just marketers, are paying attention. For Wang Fengmin, the number itself was never really the point. The point was proving that flying the materials could replace building the infrastructure to move them at all. A bet that, a year earlier, plenty of engineers sitting in that planning meeting would have quietly called reckless. It was not reckless. It was the answer to the exact problem his division had been circling for years, and this was the operation that finally landed it in front of state television cameras with the whole country watching. If that surprised you, the next entry on a very different list coming up on this channel is going to be even harder to believe. Hit subscribe so you are there when we cover it. None of this stays confined to one mountain in Yunnan. The real question now is what happens when the rest of the world's utility and construction industries start asking themselves the same question Wang Fengmin already answered. Remote infrastructure access is not a uniquely Chinese problem. Every mountainous country with a power grid, a mining operation, or a renewable energy build-out faces some version of the same brutal math. Cutting a road to a remote site can cost more than the project the road was supposed to serve, and take longer to build than the structure sitting at the end of it. Utility companies, renewable energy developers, and mining operators worldwide are watching Yunnan's numbers closely because the underlying constraint, steep terrain, no roads, a hard construction deadline, shows up everywhere from the Andes to the Alps to the Rocky Mountains. Adoption is not simple, and it will not happen overnight anywhere. Heavy lift drone fleets require trained operators, cleared airspace, insurance frameworks nobody has fully priced yet, and regulatory approval that most aviation authorities have not written rules for. China's aviation authority has moved faster on this than almost anywhere else, partly because state-run utilities can pilot programs at a scale few private companies elsewhere can match on their own. Here's a historical parallel worth remembering. Helicopter logging faced almost the exact same skepticism back in the 1970s. Dismissed as an expensive novelty, until rising fuel costs and road building expenses made it the standard method for reaching timber and terrain that ground equipment simply could not touch. It took roughly 2 decades for that shift to go from curiosity to industry standard. Heavy lift drone fleets look to be on a similar trajectory, just compressed into years instead of decades this time around. The genuine advantage here is not the hardware itself. Cargo drones are not especially hard to buy off a shelf anymore. It is the routing software, the autonomous flight coordination, and the accumulated operational experience of running 16 aircraft at once without a single collision on a cliff face. That kind of institutional knowledge is far harder to copy than a spec sheet. The ceiling that mattered here was never political. It was the cost of building a road to nowhere. And that ceiling just moved, for engineers everywhere who are staring at a similar mountain on their own project map. If the idea of engineering solving problems that used to require months of labor and a small fortune is something you find fascinating, it shows up again in a completely different form, in how China manages to build entire stadiums fast enough to make American contractors question their own timelines. That one is worth your time. Step back from the mountain, and the real implication here is bigger than one utility project in a corner of Yunnan province. Remote construction, for the first time in roughly a century, no longer requires building infrastructure just to reach the infrastructure you actually want to build. That single shift changes the math for every engineer anywhere in the world staring at a map with a mountain range sitting exactly where a road was supposed to go, from mining camps to wind farms to the next power line nobody has built yet in countries that have never heard of Sichu County. And it says something larger about every entry on this list, from the mosquito-sized reconnaissance drone to the 22,000 drone light show. None of these machines are impressive because any single unit is a marvel of engineering on its own. A crop-spraying drone is not clever. A cargo drone is not clever. What is genuinely new is the coordination layer sitting underneath all of it. The software and the operational discipline that lets dozens or thousands of unremarkable machines act like one very capable one. If you made it this far, you now understand more about heavy-lift drone logistics than most people who write headlines about them for a living. What was actually proven on that ridge in Sichu County is simple to state and genuinely hard to overstate. A fleet of unremarkable individual machines, coordinated well, can replace infrastructure that used to take a month and a small fortune to build from scratch. Not because any single drone in that fleet was extraordinary on its own, because 16 ordinary ones flying together in tight formation quietly were, and because a man willing to bet his project on that idea turned out to be right. if this changed how you think about what a coordinated drone fleet is actually capable of. Hit that like button and subscribe so you never miss what comes next on this channel. Now I want to hear from you down in the comments. As this technology keeps maturing, do you think drone fleets eventually replace heavy machinery on remote construction sites entirely, or will they always stay a supplement that only makes sense when the terrain leaves no other option at all? I genuinely want to know exactly where you land on that one. I read every single one. See you in the next one.